Hello, everyone. Thanks for joining our webcast today. I'm going to try to move quickly and cover some decent ground, but still have some time afterwards for questions. As David mentioned, you can ask questions during the webcast, and he'll interrupt if they're kind of in the context of what I'm talking about. Otherwise, we'll hold them to the end. But you'll have the option to do both, kind of questions during and afterwards. So today, this webcast will come in 3 parts. The first, I'm just going to cover some concepts for you all to consider as you think about scaling out your conservation programs. And during this part, I'm going to touch briefly on an important concept of system of record. And then I'll get into telling some stories and some examples of creating tools that have helped folks like yourselves scale out their conservation programs. And then we will finish with just a period of questions and answers, and hopefully leave some ample time for that, because I think sometimes that's the most interesting part of these webcasts. Let's get going. So when you start thinking and talking about tools, it's pretty easy to get distracted by the shiny objects, the pretty maps, the interactive charts, the visualizations, and so on. However, we've certainly found that the best tools aren't worth a whole lot if they're not designed and wielded in the service of your program's goals and objectives. Now, these goals and objectives can be expressed pretty simply in a half-page document that simply bullets out your goals and objectives, or for the daring, you can even number those goals and objectives so that there's some semblance of ranking or prioritization. Or they can be fully expressed in terms of theories of change that are supported by logic chains that are complete, have complete descriptions of threats and intermediate results and indicators, all leading up to an attainment of the target. If there are folks listening that are interested in the latter, that's topic of a whole other webcast. We do a fair amount of work with the open standards for the practice of conservation, and we think it's a great way to add a lot of rigor to your program, but also recognize that some folks aren't ready to make that leap. And but even if they're not, we'd like to start by making sure that any work that we do and any investments they make in data management infrastructures are grounded in these things. So next is making sure you have real strong and clear science guidance. If most programs need to have some type of science underpinning, and some of them have highly disciplined independent scientific review panels, and others just have more casual, occasional scientific advice. And I think all that we're pointing out as system builders, as tool builders, is before you start investing in tools, spend at least a couple hours thinking about how your scientific community can be best served by your investments. How might they interact with tools to help you scale your program and get the most out of your investment? And then last, and probably the most important, is making sure that you all, everyone going into the project, has a commitment to change. You know, we often say that creating an elegant data model, or writing great code, or really designing a compelling user experience is kind of the easy part, and the hard part's the human factor. And these tools and data management require a change in the way people do work. We try hard to integrate new systems into the workflows that already exist and make it as streamlined as possible. But the one thing that's constant is change when you bring on new ways of managing your program's information. So before you go too far down the path of investing in tools, you know, get some commitments from your stakeholders, your boards, your senior management. Think of these commitments as your construction bond or your casualty insurance before you start walking down the tool aisle or start putting on your carpenter's belts. All right, so now that with those things in place, you can start talking about the right tool for the job. Thing that I think we probably all have seen in the last 10 years is that programs require answers and not just data. I think it used to be that you could, you know, check the box of transparency and consistency and data-driven support systems if you just had a database. And now most conservation programs have at least one database, if not many, in their back office to run some part of their operations. But I think it's important to keep in mind that databases alone just get you data, whereas well-designed tools can get you answers. Modern conservation programs need to efficiently track activities, expenditures, accomplishments, and traditionally programs have done this for years. Often that data is just destined for an annual report or a ad hoc fact sheet for a project for your meeting with a constituent. You can get by with not all that sophisticated tools. They can be pen and paper or spreadsheets. But when you want to scale out your program to allow more people to interact and engage with it in more real-time ways, there's an opportunity there to invest in a little better tooling. And certainly for some of the folks out there, they're running programs that deal in ecosystem services and quantifying them and dealing with credits and debits. The chain of custody impacts the need to have a strong evidentiary chain is really important so that that market can flourish and have confidence. So that also kind of ups the game and will have some impacts on figuring out what the right tool for the job is. Built right, these tools can really help you scale your program. Okay, last kind of high-level concept until we start getting into some examples and some storytelling is the system of record. And the system of record is really it's a pretty simple concept. It's something that I think as system designers we take for granted, but I've learned over 15 years of building systems for folks like yourselves that this is a pretty important one for business users or conservation managers or anyone up and doing the kind of work that you guys all do, is to keep this in mind. And the system of record is it's the authoritative source. It's the source of truth for any given element within your program. It might be a project, it might be a funding source. And as tools designers, we often talk about where the CRUD happens. And by CRUD, that's create, update, and deleting of records. And as the second bullet points out, you can have more than one system record within a program. You just don't want to have multiple for the same thing, because when you do that, you've got multiple places to update information. You have chances for information to diverge and be contradictory. And so just make sure that for each component of your program, just be real clear what is the system of record. The table down below is a rough sketch of types of systems of record. On the vertical axis and across the horizontal is maybe some dimensions or things to consider as you vet whether or not you've got the right system of record for the component of your project or your program. The first column really gets at the number of people that can concurrently or simultaneously be updating information in your systems. And so as you go down in sophistication, you can support more simultaneous engagement of your staff and maybe volunteers or even folks in your external partners. Next, you really want to consider about your reporting and analysis capability. A lot of folks like to combine those into one column or one dimension. I think it's important to separate out reporting from analysis, because frankly, you can get by with less of an investment if all you need to do is report. But a lot of folks need to do some analysis as well, which is kind of the essential part of an adaptive management loop. You need to be able to kind of do that synthesis and figure out how the actions on the ground need to be adjusted per the results in order to get the right result that you're looking for and obtain your outcomes. And then last is taking a look at partner and stakeholder transparency and how important is it for your partners, your funders to get close to real-time access to what's happening. So if folks have questions on that, it's a little bit of a dense topic, but happy to field some at the end. Okay, so we have a few different examples. Like I said, we've been at this for a while. We like to talk about building scalable knowledge infrastructures. And here are 4 examples from over the last, gosh, I guess 4 to 5 years. Some of them are more recent. I'm going to spend a few minutes on each and try to give you a little bit of context of the problem that the tool was designed to solve, how it helped the program that we were working with scale out their program and increase their capabilities or their capacities, and then focus on some of the real world benefits that were derived from that. My hope is that these examples give you some things to think about as you think about scaling out your own programs and building your own tooling. And if anyone's interested in playing around with these tools, I think most of them have the ability for you to get in there and play around yourself, and we can provide you some information about how to do that afterwards if you like. All right, so first, to talk about some in the field iPad data collection and automating metrics for a really large monitoring habitat status and trend monitoring program up here in the Columbia Basin. Then a much smaller scale, an example of using some newer technology to automatically do change detection based on image analysis and kind of using computer vision techniques to understand the extent of growth of invasive species. Then we'll move on and talk about a web app that has an online mapping tool to support the consultation process for folks who want to do some development in an area that could potentially disturb sage grouse habitat. And then last, we'll talk about how the Lake Tahoe region has built out an entire platform to help engage their partners and stakeholders and scale out their reporting and analysis, and kind of all the way up to some dashboards that that are automatically generated from the underlying data. Okay. So first, the Columbia Basin Habitat Monitoring Program. This is a rather large program. About 7 years ago, a couple federal agencies contacted us to get some help designing a system to help them manage the raw field observation data, to help organize crews before field season, to track landowner contacts, to make sure that they get access to the land. And then ultimately to automatically generate metrics and indicators from the data to help answer some management questions. And so given the size of the area, it's about the size of the country of France, and the fact that they're dealing with so many partners, they knew from the get-go that they needed kind of that bottom option in the prior system of record table. They needed a web-based system of record to manage all this information. And so the solution, it was a web platform to handle all that. Like I said, it supports the site evaluation and landowner coordination. It has automated data flows between the back end and the front end to the iPad minis that are out in the field for collecting data. And it does a lot of automatic metrics generations and running of models to do some pretty advanced calculations on average pool volume, for example, in the stream channels. And so the results have been really good. They've, on the bottom bottom left, you're seeing just a quick picture of someone working the iPad out in the field. That tool has iterated and evolved quite a bit to streamline the user experience and to allow them to scale it out to send more and more crews out there. And then on the right, it's a small picture, but a really powerful view that we were able to co-design with the folks running the monitoring program to help them keep an eye and a sense of where the whole monitoring effort is at during the middle of the field season. So you're looking at, how many sites have been visited, how many are in process of data collection, and how many have not started. At the overall program level, there's over 400 sites visited every field season, every summer. And then down below, you see the same chart for each of the watersheds and each of the crews that are out there. So kind of a command central that really lets folks at our operational level understand what's going on and where crews might need some additional support. The cost savings were about $19,000 per watershed per year. And this has been going on for, I think we're going into our 6th or 7th field season. So when you do the math and consider that there's, I think now 14 watersheds here, savings of well over $1 million over the course of the project. So pretty significant in terms of the day-to-day operational savings and allowing them to scale this out to the number of people that they have. So in summary, they were able to lower their costs by streamlining the access. They greatly increased their quality and confidence in the data, and therefore not just the raw data, but the metrics that were derived from it and the indicators. And so those management questions could be answered with a lot of confidence. And then last, really provided a way for them to have a lot more control over the entire monitoring program, from landowner coordination all the way through to generating dashboards that summarize the answers that have, to the questions that managers had. All right, I think, yeah. So it's a pretty big program. To date, it's like 2 terabytes of data in the system, and like almost 3 million files that have been collected over the course of the program. Sorry, Damon, was there a question?
Yes, we actually do have a question for you. The question is, my program is a lot smaller than the Columbia Basin program, but I'd like to leverage mobile data collection and gain some data transparency. Will the system you're describing right now work for an agency that's smaller and with fewer resources than the Columbia Basin program?
Yeah, that's a great question. We've had that a few times. We get that this program is unique in its scope and scale. The good news is the systems that were built to support them were done with ratepayer dollars, and so that system is available to others to use. What Sitka has done is packaged it under a platform called GeoOptics, and even then, there is kind of a minimal size. I think we often want to talk to folks and see how many crew do you have going out there, how many people collecting data, how many sites do you need to visit in a field season. And I'll be honest, when it's really limited, pen and paper is probably the most efficient, because you don't have that much transcription and things to do. But once you get above, a few technicians or data collectors going out in the field and more than 20, 30, 40 sites that you need to visit, then it starts to make sense to talk about how to scale it up with some better tools. So we've got some case studies and information on GeoOptics on our website, and I'm happy to follow up with whoever asked that question afterwards.
Great, thank you. Just before you proceed, I just want to, we've had more people log in during the course, so just in case you don't know, if you're listening today, you can ask us questions via the Q&A console. So at the bottom of your screen, you just click on that, and you can type in a question that we'll ask at the end, or if relevant, we can sometimes interject at appropriate times. Thank you.
All right. So the second story is around, it's a much, much smaller scale. This was more kind of a fun little project that we did with the Columbia Land Trust. If folks aren't familiar, the Columbia Land Trust is one of the larger land trusts in the country. To date, they've conserved over 32,000 acres of land in Oregon and Washington. And one of the many things that they do is manage their lands for invasive species. And in their neck of the woods, one of the nastier ones is reed canary grass. And after hearing about our ability to acquire high-resolution imagery using UASs, or unmanned aerial systems, or what the rest of us often call drones, we just like to say drones for good. Once they heard about our ability to do that and then do some post-flight image processing in order to automatically generate metrics, they called us up. And the project was to see how effective this technology would be to automatically detecting the extent of reed canary grass, both in the dormant season and in its more at the height of its growth. And so that's what we did. There was 2 sites, both one about 250 acres and one about 300 acres in the Columbia River estuary, about 30 river miles up from the mouth. And one of the challenges with this project or these sites is that they're tidal wetlands, and so it's pretty hard to get crews in there in boats and to do your traditional stick and tape measurements and transects. And so we went out there and flew the sites in a day. And in the bottom left, you can see the control area where it was not treated. And then on the right, the segmented, the treatment I'm sorry, the area or the site that's been treated. And it's a little bit hard to see at this scale, but you see the pink areas are areas where there's been treatment, and then the yellow is kind of a computer applied areas or interstitial regions that the image processing software detected after the fact. And so that's really the raw materials for us to help measure the interstitial areas and to do metric calculations after the fact. So the result was that that we generated a 1.6 gigabyte orthomosaic of these sites. That's the first picture there. That's just one little segment of the picture. We've crashed a few computers just trying to get them to display an image of that size and that resolution, but you're getting down to 2.5 centimeters. And because it's all georeferenced and orthorectified, you can do pretty precise measurements off of that image. One of the other outputs is the middle picture there is a point cloud. This is a point cloud of I got the number here. Let's see, 233 million points in that point cloud. Maybe a little bit hard to see, but in the middle of it is a truck with a hatch open. So you can kind of see this is or an oblique view of the site, and can be very helpful for a wide range of metric generation and also for getting a really good baseline picture of your site, maybe right when you acquire it or before you start doing a lot of work on it. And then the nice thing about this technology is that because we use flight control software, you can refly the exact same site 6 months down the road, 12 months down the road, 5 years down the road, and the drone will actually follow the exact same path. And because the first site has generated, the first visit generated a local reference plane using a ground control and an RTK device, you can reestablish that coordinate system, and your change detection and measurements across time can also be very precise. And the last is a digital surface model that is generated there's output from the flight as well. So the benefits of this tool that helped CLT kind of scale their baseline data in the small for these couple of sites and really more of a pilot was that we decreased their cost significantly. You know, it took a couple hours to fly each site versus walking and boating it in a couple days. It also completely eliminated data entry and transcription. Quality and confidence, of course, go way up when it's that automated and you have that level of precision that you just can't get by traditional data collection or monitoring methods. And then your metrics are also automatically generated. And then last, you've got this really high resolution asset to establish the baseline condition of an area. And then last, their capabilities to do change detection were kind of new capabilities for them. And to be honest, there's a whole range of ideas of how they might be able to use this information going forward. So I think that story is still being told. All right.
Yeah. We have a question here basically about what software, if we know what software was used to generate these products. I believe it was Pix4D.
That's right. Yeah, there's a couple different packages that we use. Yeah, to be clear, Sitka's capabilities or smarts don't get into image processing, so we're using third-party tools to do that. I think Pix4D was the image processing software, and I can get more. I'd be happy to follow up with a little bit more details on the full stack that we use, the full technology stack we use for that. It wasn't something that I was directly involved with, but happy to follow up.
Great, thank you.
Yeah. Let's see, I think that's it. Any other questions, or should I move on there, Damon?
Please proceed.
All right. So third story is around helping the state of Montana with meeting its commitment to federal regulators to run its own consultation process for folks that have proposed disturbances in sage-grouse country. So if they do this well, they can avoid an ESA listing. If they don't, they might lose their autonomy to manage their own land. So the stakes are pretty high. They had an initial effort internally with their IT group to build just a really simple one-page web form to collect information to kick off the consultation process. And one of the things that they learned is that web form just wasn't, it couldn't collect enough information. It wasn't smart enough to deal with the different types of projects, et cetera. And so we took a long, hard look at that and figured out a way to collect a lot more information with the least amount of effort by the landowners and developers who were in there proposing these projects, and to speed up the entire review process by automating it. So scaling out this part of the program was really important, and the results have been pretty good. This project is about ready to go live in a couple weeks. We'll be on the ground in Montana as we turn it on, and it's in kind of testing with a whole group of external users as I speak today and the rest of this week. So the solution was a streamlined web app that has some built-in online mapping, and the user that we really focused on were these land users, developers, as well as the state staff reviewers and people that need to run that consultation process. And a little bit of a geeky part of the solution is that it runs a density disturbance calculator, so it actually quantifies the impact of the proposed impact on the land. And we needed to figure out a way to do that in real time. It used to be that they'd submit the stuff, and then in the back office they'd crunch through, run the calculator, and then they'd have hours to do that if they needed to. What we were charged to do is see if we can't figure out how to do it in real time to help those landowners propose their disturbances and then immediately see the impact, then be able to adjust their project design and see if those adjustments can lower their impact. And by really providing the right tools for landowners and developers and make them real-time and responsive, the sage-grouse habitat can be better protected, and financially they have less mitigation to do. And so it's kind of it was a neat project to put good tools in the hands of the folks that most need them in order to have the best results. And so, sorry, the last geeky part was in order to pull that off, one of the things we needed to do was convert that calculator from Transact SQL into Java. In other words, move that core part of the system from just being wrapped up on the back end and the database side, and really create a real middle tier where business logic can run and do a separation of the systems. And maybe a little bit geeky, but the idea is you want to have a good multi-tiered structure to your tools so that each part of the system can evolve independently when the business or operations needs change. And you can do that at least cost if it's architected well to begin with. All right, so the results we came up with an interactive guided proposal process that has full auditability, so everything is kind of logged and tracked. And then there's a dynamic questionnaire that is built on the fly depending on the answers to other questions and how they filled out or described their project. And it also provides a really consistent experience for everyone involved, and it's a lot more predictable on what's being asked for when. So the pictures down below are just a few of the steps, the first few steps of the wizard or this proposal process. The next few slides, they go into a little bit blown up so you can see them a little bit better. So the first step is just giving them some instructions on what's required. They can pull up the statewide map and determine if they even need to go through the consultation process. They got a lot of submissions in the first version that didn't even need to go through the consultation process. So we're hoping to streamline that quite a bit for the reviewers. The first step looks like a pretty basic, perhaps boring web form that just asks for a name and a project type and some basic information. And then it gets into the little bit more fun stuff where users can draw on the map, or they can upload a GIS file of their proposed project. Down below, they detail out what type of disturbance it is. And then below this, it's kind of, you can't see it in the screenshot, is the ability to click a button to run the density disturbance calculation and get a quantification of their impact. The red circle over here is actually the border of a buffered lek, or an active breeding ground for sage grouse. And so the distance between that LEC and this proposed disturbance is going to be one of the factors that's an input into the calculation. All right, so wrapping up the benefits on this one, they were able to really lower their upfront costs by reducing the time to complete a consultation. That's the cost for the landowners and the developers as well as the reviewers. I don't have actual numbers on that yet, just because it hasn't gone live yet, but we're looking to actually measure that and see what kind of savings we can get or they got. They also lower the O&M cost by moving that calculator and architecting it in a way that allows it to evolve and change as science improves or as techniques improve to measure impact without messing up the user experience and without dramatically changing the database. And so we feel good about leaving them in good hands with that part of the system that will really be built to scale as their program changes or regulations change. And then they were able to lower their risk quite a bit. Like I said at the beginning, the stakes are pretty high for this project. And the more you can standardize the workflow and provide a consistent experience, you really can lower your liability. And then the system also affords a kind of full tracking of the audit history with each stage transition. When it moves from draft into due diligence into final review, the system automatically takes snapshots of the project map because the underlying layers may change, which are inputs into the calculation. It also takes snapshots of the density disturbance calculation tool runs, so you can see how the score may have changed over time as the project's been adjusted. And then lastly, their capabilities have gone way up in that they've got automated reports for stakeholders and federal partners. So I think that's what I got on that project. Make sure I covered my notes there. Yeah. All right. I am going to move on to the last example, and this is some work that we've been doing with the Tahoe Regional Planning Agency for many years. They are an organization set up by a congressional act because they are managing the Lake Tahoe Basin, which is divided partially in California and part in Nevada. And so they oversee the long-term development and environmental restoration projects in the region. So they're a permitting agency, as well as they've been set up as the administrator of the Environmental Improvement Program, which has been going on for over 20 years now, and it's spent invested $2.3 billion in a wide range of restoration projects, science monitoring, and things like improving scenic beauty and transportation projects around the area. They're not the funder. And so one of the challenges is, how do we scale out this program and get better data to be able to answer questions of legislators, assistants, and congressmen and senators without having it be a 2-week fire drill and diving through the file cabinets. And yet, since they're not funders, they didn't have much of a stick to require folks to provide information. So they did what a lot of you guys probably do, is periodically put out a data call and ask people to send data in, and it comes in all shapes and sizes, and then it's another few weeks of corralling and massaging and conforming that data so that it can answer questions. So what we did is took a different approach and built a small little web app to start off with that would walk their partners through an annual project update cycle. Our goal was to let them do it in 5 to 10 minutes, and I think, except for the most complicated projects, we've met that goal. The challenge, of course, also is to kill that 23-tab spreadsheet that I'm sure you guys have a few of out there that was actually the system of record for managing all this project information. And so the other kind of goal we had in the solution was to do this in a way that didn't require any training, and then obviously to have all that information roll up and feed automatic reports and dashboards. So the results have been great. They've been really happy. The 5 to 10 minute goal has been met. And as a result, all this data is in a system, and it enables longer term strategic planning and collaboration. So this is the part that really enabled them to scale out their program. And then these the screenshots down below are a few examples of some of the visualizations or summaries of information provided by that project update cycle. So in the bottom left is a map of Placer County in California, and just showing for them, like their custom view of what are all the projects that we have either funded or we have led the implementation on or supported the implementation on. And I can look at those projects a number of ways, by their stage, by the type of project, etc. In the middle is, and the next few slides, I'll give you full screen views of these. I know it's kind of hard to read as they are, but in the middle is just a summary of the funding, the expenditures by funding source. So they were interested in how much money is coming in from private sources, from the state of Nevada, from the state of California, or from federal. And then last, a key part of this program and scaling it out is being able to automatically report on a set of 34 performance measures that they had set up. And one of the secrets of this success of this project was Sitka being able to partner with environmental incentives. And all they do is help folks create and design performance-driven conservation programs. And so they had done the work to help the region identify and select these 34 performance measures. And this one, Acres of Habitat Restored and Enhanced, is just one of those. So there's a little larger picture. This is the web page that summarizes Placer County's involvement in the region. So the first is just an overview. The system, the Environmental Improvement Project Tracker, is one of a host of tools within the platform. The other things it does is it tracks development rights, rights of way, and other things that as a planning agency, TRPA and its partners were very interested in. It used to be that information was only available upon document request, and now we're able to daylight a lot of them because we have a platform that can share some infrastructure and scale out to support these other components of their work, of their organization. There's a blow up of this particular chart is just looking at one of the 63 watersheds in the Tahoe Basin, Bijou Creek, and it's showing over time where money, how much money has been invested and from which sources. So Bijou Creek is right there in the south part of the lake, close to or within the, I think, the city limits of the city of South Lake Tahoe. And last, this is the stack bar chart of the one of the performance measures, Acres of Habitat Restored and Enhanced, and you can see the types of habitat that have been enhanced over time. And you can kind of get some trends and answer some questions and maybe ask, why was it so low in 2015 and what did we do to pull off the big numbers in 2010? So these are the types of analysis questions you can start to ask when all your time and energy is not consumed with data corralling and simply creating reports. All right, summarizing, like a lot of the other efforts to scale out programs, a lot of it's about lowering cost. And they were able to do that by automating analysis and reporting and visualizations. Got rid of a bunch of paper reports and were able to more easily and quickly answer those probing questions from constituents and stakeholders. And then the quality and confidence in the data, we've already talked about this a bit, went way up. And people like it when they get to live data and they see how, when they update their project, how it moves the bar and the needle is moved on that chart, for example. And then increased capabilities by freeing up staff. So their TRPA has an entire research and analysis division that came on board part of the way through working with us. And a lot of the tools we've been building have enabled them to do that analysis and, like I said, not to spend all their time corralling data. Yeah, I think that's a good summary there. And I guess that is the end. That's the 4 examples I wanted to share with you all. I think we should like to open up for any questions and certainly happy to talk a little bit more about how these things have helped these programs scale, or how you might think that some of these tools or techniques might be helpful for you, or going back to the original part of it on helping you figure out systems record or what have you.
Thanks, Matt. I think that was great. And I think you only said geek like maybe 10 times. So.
Oh, okay, that's good.
We like geeks. They're all good. They're the new
Know
black.
your place.
Yes, no, they're good. Anyway, so I do have one question in queue right now. If anybody else has a question about any of the engagements that Matt shared about, we're more than happy to address those. So please ask. You can either do so via the Q&A or even the chat. You can do that as well. Either way, we can get your questions answered. And also, before I get to this question, a lot of the engagements that Matt talked about today, we do actually have more information on our website, case studies, and et cetera, and some that are in process. So please check or follow us on Twitter or check out our blog, things of that sort. But the question for you, Matt, is our organization collects both long-term data sets, such as water quality, and short-term data sets like project implementation monitoring. However, we are limited in how we can use the data due to budget and time constraints. Do you have any recommendations on how best to get started? And if there's maybe one of the engagements you highlighted, if there's a story from that, that would be great.
Sure. Yeah, I think that I don't want to scare anyone away from the goal of scaling out your program, thinking that it needs to be of the size of the Columbia Habitat Monitoring Program, for example. There are, like I said, earlier, that the tools that we built for those clients are available in more abstracted, simpler forms, frankly, for programs of different sizes. But I think before even getting into tools, if you have a small program like that, I think going back to what I talked about to begin with, really slow down and spend some time thinking about who needs the information that you're collecting in your monitoring programs, and where's that information being created, and how many people need to be involved, and kind of walk through that matrix to help figure out where you should be at this point, or where you might want to be in a couple of years, because it's easy to overinvest in tools, and maybe that's a bad thing for me to say as a technologist, but we really do believe in finding a right size solution for conservation programs, and sometimes it's small adjustments that can help you scale up the program a little further. And then once you get on that plane, you can see further. You can understand what your other options are from that point forward. So I think start with a little bit of looking within your organization on who needs access to that information, and on kind of what frequency, and then we can start talking about tools or ways you can scale it out.
Great. Hopefully that was very helpful for them. I have one other question that's in queue. Oh, actually, here, let me see. There's two now. 1 second. Here's a question. Do you have any projects where you are working at a national scale? I work for a very large organization that is interested in dashboard capabilities, tracking national and regional level performance measures information, and sharing this information with stakeholders across the entire United States. And can it pull from existing data sources for the dashboards, or does it hold the data too? So it looks like a couple questions in that one.
Yeah, good question. We work with a lot of federal agencies and state agencies and regional agencies like TRPA or Metro here in Portland, which is a pretty large organization. But and I guess the other thing that we're doing more and more of is working at a national scale with monitoring practitioners. We have another tool set that we built with USGS that I didn't have a chance to go in today, and that's geared on towards creating tools to help monitoring practitioners be more efficient and have better tooling for running their monitoring programs. That's less about tracking individual data records and more about tools to help people develop study designs to manage their sites over time, and then to manage their different data sets. And so that, I encourage you to check that out, and that whole system or program is called monitoringresources.org. And we're talking with, we're doing a project with BLM to help them scale out their bat monitoring on a national scale right now. I'm less directly involved in that project. We can give you more information on it if you like. But I think the other part of the question was, do we ever work we build systems that reach out to other systems and get data and pull it in, or is all the data contained within the systems that we typically build? And the answer is yes, we do both. The dashboard that we built for Tahoe Regional Planning Agency under the laketahoeinfo.org site, that has a mix of what we call organic performance measures or indicators and foreign indicators. Organic ones are those that where all the data underneath that chart is driven from information and data records and database tables within the system. And a foreign one is where that information is held. The system of record for that may be the Department of Transportation for Nevada, or Caltrans in California, or their sustainability dashboards that are pulling in educational test scores at the state level. Those, we have built out that system so that an administrator can come in and enter in a derived metric. So the average annual value for the test scores, or for the number of roads treated, or ozone, 8-hour ozone for the course of a year, for example. But we typically also build out web services in each of our systems so that folks can reach in and get data programmatically from the system, or we tap into other web services from other databases and other systems in order to pull data in. So we do both things, and the latter of leveraging external data sources that are already there is certainly, we're seeing more and more of that type of work, which is encouraging. It means we're not out there building yet another database, but we're leveraging the ones that are there and daylighting that information and making it available in different avenues.
Great. And then also Marathi with the global, the worldwide usage.
Yeah, yeah, absolutely. We do a lot of work. I mentioned at the beginning with the open standards for the practice of conservation, and that's work that Nature Conservancy has put a lot of effort in, as well as a lot of other global NGOs. And yeah, there's a global community that are using that tool set to both capture their theory of change and as well as track the results from different monitoring efforts and indicators in order to feed an adaptive management loop. Yeah, thanks for pointing that out, Damon. I lost sight of that for a second.
Yeah, no problem. Before we have another question in queue, which I'm going to ask you, Matt. I do want to let everybody know that I am recording today's webcast, and I will be posting it to the Sitka website, and it'll also be kind of broken up into chapters. So if there's a certain area you'd like to share with colleagues or revisit, you can do so. And everyone who registered, who's on the call today, will get an email kind of letting you know that it's live. So another question that we have on queue, and thanks, Matt. There's Matt's contact information for future and reference. And we have another question here about the sage-grouse habitat calculator. Does the sage-grouse habitat calculator aggregate project-specific impacts once a project has been approved to the regional statewide scale? And then the second part of that is in what ways are regulators analyzing the data?
I think I understand the question, and the answer is yes, it does aggregate, because what happens is someone submits a proposed disturbance. That submission date is critical because it is kind of a first in line program that they defined. So if landowner A submits something yesterday and landowner B submits something today, landowner B's impact takes into account the proposed disturbance from landowner A. And so that's all part of the density disturbance calculation, and because they pull in both proposed or preliminary disturbances as well as existing disturbances that are on the landscape, and that's all kind of factored in, and it allows the program to manage the sage-grouse impact by sage-grouse area or zone, and also by BLM priority order. BLM priority area. And then the second part was about regulators, and that I think is a little bit to be determined, to be honest. What we have built out is
a pretty robust system to collect all of the materials to support regulator requests. We identified regulators as a potential user of the system in our initial user task analysis that really focused the software project, the system project. And yet we haven't built like automatic pushing of reports or data to regulator users, but there's no reason they couldn't get into the system, get an account, and get some of that information themselves, or you know, the client, the Department of Natural Resources and Conservation, who kind of houses the sage-grouse habitat program within Montana. It's mostly their job to coordinate with federal regulators, U.S. Fish and Wildlife Service and BLM, and to share the results and what they're doing. We have done some things like integrated some threat classifications that they require. So the review process allows the sage-grouse habitat program reviewers to flag those threats in order to drive those kind of reports. So we're, in summary, I'd say we're in good standing to support a wide range of regulator reports and requirements and flow that data to them. But the cadence and the details of that, I think, are still being worked out. And I know that the principals there, the manager of that whole program, is in very regular conversations with those folks, as well as all the constituents and stakeholders in the state. So I hope that answered the question. If I didn't, please don't be shy, and you can re-ask it in another way.
Okay, well, I think that's it for today. I don't have any more questions in queue. Thank you, Matt, for taking the time to share all this information with everyone. Thank you, everyone, for joining us today. Greatly appreciate you taking the time. And looks like maybe, and the person, just so you know, Matt, the person that asked that last question was happy with your answer. So.
Oh, good.
Yeah. Great feedback. All right. Well, thank you again.
All right. Thanks, everyone. Hope you have a good rest of the day and the rest of the week.